Hello, everybody. Today I'm going to talk about how integral and differential calculus is applied in my career, civil engineering. Let's start. It's civil engineering, the discipline that shapes the world around us, from the skyscraper that rise majestically to the bridges that span mighty rivers. It's also the art of combining innovation and creativity with technical precision to design and build infrastructure that transform communities and cities and also improves people's quality of life. In civil engineering, each project is a unique challenge that requires a meticulous approach and careful planning, from the initial design phase to construction and ongoing maintenance. Civil engineers must consider many factors, including safety, sustainability, efficiency, and environmental impact. As you can see in the first image, is related to population, and population is a problematic that many cities around the world have. For example, Tokyo in Japan, Hong Kong in China, and even Mexico City in Mexico. And a civil engineer needs to take into account these problematics to solve these problems and also to reduce the environmental impact. In the second image, we can see the traffic jam that it's another problematic around the cities. And well, the engineer needs to be wise and clever also to solve these problematics. And one option to solve it could be to build a subway train, for example, or maybe to distribute roads and bridges around the cities. In the last image, we can observe skyscrapers and buildings. And actually, I have seen a video on TikTok related to these challenges or problematics, and it was about the challenges of civil engineering in Saudi Arabia. And why a challenge in this country? Because, well, as you know, this country, well, many part of this country is desert. So the ground is not solid, it's actually sand. And, well, the important part is how civil engineering designed the foundations because well actually the foundation needs to be deeper than a normal way because if the foundations wouldn't be like this the skyscraper the building could fail down. Well, this course benefits from the use of integral and differential calculus. And what are there? Firstly, differential calculus is a branch of mathematics that uses the derivative as a ratio of a change and variation with respect to time. And the variation could grows, decreases, or maybe remains constant. On the other hand, integral calculus is divided in two parts. The indefinite integral, which is something that we are seeing on mathematics class, and it's simply to use the term antiderivative, and the definite integral, which helps in the study of loads, areas, volumes, and charge of the infrastructure. Now, the application of differential calculus in this field. The use of the derivative in the engineering is mainly concerned with the reduction of cost and the use of more space. And well, the choice of materials depending on the condition of the region, for example, the weather and the distribution of works. In this image, we can observe an engineer visualizing a city. Since a derivative can help us to study the growth and expansion of cities, It's used to analyze development patterns, population growth rates, and infrastructure needs. With this information, the engineer will have a broad knowledge to design and develop more efficient buildings for the number of inhabitants, taking into account sustainability and environmental care. However, it's not just about building bridges, skyscrapers, houses, or buildings. It's about building a better future for generations to come. Civil engineers are the forefront of innovation, using new technologies and techniques to address the challenges of today's world, such as climate change, rapid urbanization, and resource scarcity. The theodolite is an instrument where we can see a spitting image of the terrain and also helps to measure the imperfect terrain. And with this information, a derivative can help us to calculate how much soil is needed to fill the surface so that later a good foundation can be made. Undoubtedly, the strong point in this branch is the use to calculate the distribution of roads. As you can see in the first image, several roads are used to improve the traffic as well as taking care of the environment. And well, eh, another point is the decrease of cost in a work and the exact use of materials, the correct choice of material, just as I used it in the optimization problems. Finally, these images are also of drainage distribution, canals, and hydraulic pipe distribution in a factory, for example. Now, how integral calculus is applied on this field. As I mentioned, integral calculus helps to calculate areas under the curve and volumes and loads of bridges, foundations, and dams. In this image, when designing a building, it's important to calculate how many beams and columns will support all the weight, as well as the type of foundations that will load the whole structure. As you can see in this image, there are many kinds of bridges. For example, suspension bridge, arcade bridge, beam bridge, and cable stayed bridge formation just once. But well, as you can see, the shape of the bridge changes depending the shape of the river. For example, in the first image, we can see a river with a curve. And well, in this case, the better option to build a bridge could be to a curved bridge because, well, there are two rest points. But if we can see in the other side, there is a bridge with a river in red line. So there aren't rest points. So that's why the engineer needs to design the current foundations. And well, in the other bridges, the river has an imperfect shape, so the foundation change depending the river, as I said before. Lastly, the integral is crucial when it comes to large scale works or complex scale works, such as dams, as you can see in the image, and where the magnitude of the load is very high, because well, the engineer need to take into account many factors, as I said, on the beginning. For example, the pressure of the water, right? And also, as you can see in the image, the distribution of drainage, and also the safety of nearby buildings or cities or communities. What would happen if calculus were not applied in the profession? The first point on safe designs, as we can see, without the use of integral calculation, it wouldn't be possible to calculate loads, stresses, and deformations, which would lead to unsafe constructions. The next points, there are inefficiency in the use of materials, and the third point, unnecessary cost. As we can see, the derivative is applied or is used to reduce cost and the choice of materials, and well, the lack or excess use of materials, as well as unnecessary expenses. Now the optimization problem. The problem is about that there is a river of 100 meters, and also there is an electric plant in a side of a river, and 500 meters of river there is in the other side a factory. And well, the problematic is that an engineer needs to build a cable, but the cable, well, the cost cable change depending the part of the river. In the short cable, the cost is 7,200, and the water cable, the cost of the water cable is 12,000. And well, as you can see, there are the data, the short cable cost and the water cable cost, and also the distance from the shore. There is the x minus 500, right? And also there is the general function, because we need the general cost of the work. And well, it's very simple. The function is the cost of the short cable times x, plus the cost of water cable times y. And well, the next function is the calculation of y, and it's very simple because, as you can see, there is like a, rec- a right triangle, and well, I use the Pythagorean theorem, and well, I have the data of this part, and well, the data is the 100 meters of the river squared plus the measure of the short cable, that is 500 minus x squared. And well, then I developed the function, and it would be it. The next step is to substitute in the general function the value of y that it was that we calculated before. And and well, having the general function, we need the first derivative, and well, we need to find the critical point. And as you can see in the graph, in the first derivative graph, the critical point is gonna be equals to 525. Having the critical point, then I need to calculate the second derivative. And well, after to calculate it, I'm going to substitute in the variable x the critical point. And well, the result is 256 over 25, and it's greater than 0. So this result indicate that it's a minimum, and well indicate that the critical point is correct, and also indicate the distance in the shore of the river, and it's gonna be 425 meters. The next step is to calculate the measure of y, and having the measure of x in well that it's equals to the measure of the shore. We need to substitute in the function of y that we calculate in the first part of the problem, and well, I'm going to substitute in the variable x as well, and well, we obtain the result that is 155 meters. Uh, Having the distance of the shore and water cable, I calculated the general cost, and I used the first function that we made, and well, I just substitute the results of the distance in the variables, and well, the result is 4,560,000 pesos. Finally, there are the values of the results of these problems. There is the x that is equal to the shore cable, and y that is the water cable, and also the general cost. And thank you so much for your attention.